Okay, this is 9.7, example 9.7 from Discovering Design with Chemistry. And it says a chemist dissolves 50 grams of MgNO3 to magnesium nitrate in 275 grams of water. What is the freezing point of the solution? So let's start with, where do we start with this? So we have water and we've got something dissolved in the water. Usually the freezing point of water would be 0 degrees Celsius, but that's going to change because we're adding something to it. In fact, we can just erase this because we know when we add something, it's usually going to make the freezing point drop. Hence the minus sign at the beginning of the equation. So let's find all the pieces. What do we have? We want to find the freezing points. We want to know how much it goes down by, which means we're looking for not necessarily the change in T as our final answer, but we're looking for the change in T so we can get to our final answer. And then what do we have? We have 50 grams, which is not anywhere in the equation. This is the number of molecules that this thing breaks into, the number of particles, I guess I should say. And then this is a predefined number for each different substance. They've given it to us for water, so we have that. And then this is our molality that we've just recently dealt with, which means it is the moles of our solute. And in this case, what is our solute? It is this. Let's label it. And we divide that by the kilograms of the solvent. What is our solvent? It's water. So we need to convert this to kilograms, and we need to convert this to moles. And once we've done those two things, we can plug them in, find the molality, and then we'll have all the pieces we need. We'll have our K because it was given, we'll have our molality because we find it, and then the I is the other thing that we need. And we can look at our solute to see how many things it breaks into. So we have one thing here, and this is going to stay as a set. It's helpful having the parentheses because that helps you see that it's going to be that way. And there are two of them, and so that's 1, 2, 3. So our I in this case is 3. So we have the I, we have the K of F. Let's do the molality. So let's first convert our 50 grams. So 50 grams of magnesium nitrate. And we're going to multiply that by its conversion factor to get that. We've done this several times, and so I'm not going to go through how to do this again, but we can add up 1 mg, 2 N's, 6 O's, and get the atomic mass unit to be 148.33 grams. And then our grams will factor out, and we'll have the number of moles that we need. I'm going to put it on this side so we can keep our numbers all together. All right, so 50 divided by 148.33. And we get to keep 3 significant units because that's all the 50.0 had, so 0.337. So 0.337. So if we're keeping track, we now have our I, we have our K, and we have our moles, which is half of the molality. All right, let's do the kilograms now. So we have 275.0 grams, and we need to convert that to kilograms. You can move the decimal, you can use a conversion factor, whatever you want. This one, grams to kilograms, means we're going to move it this way. So 0.275. 0.275 kg, and that's our solvent. Now we have the two pieces we need to solve for molality. So our little m is going to be the moles divided by the kilograms. .337 divided by 0.275. All right, so we get to keep 3 significant digits, so that's 1.23. So 1.23 m. So we now have everything we need to solve this. So let's make this a little bit smaller so we can continue down below. All right, so our change in t is going to be -3 times 1.86 degrees Celsius per m times 1.23 m. Our units cancel. The 3 is, we have to remember that the 3 doesn't count when we're thinking of significant digits because we can't have a portion of an ion, and so that 3 is exact. So we have -3 times 1.86 times 1.23. All right, and so we get -6.8634. The 1.86 is yeah, that one's not exact, so we have to count that one, and then the 1.23 we calculated that, so we get 3 significant digits, so -6.86, and our units is degrees Celsius. Now this isn't the answer. Let's go back and look at what the question was. The question asked, what is the freezing point of the solution? In other words, what is the freezing point of water with this magnesium nitrate mixed in? So what we just got was a change in T. In other words, we got this number, and that tells us what the freezing point is. In this case, we're subtracting it from 0, and so 0 minus 6.86 is indeed still 6.86. You have to be careful because if you're starting with a different solution that's not water and the freezing point's not 0, that change in T just tells you what you have to drop it from, whatever that substance's normal freezing point is.